Okay, the purpose of this video is to show you the interference pattern for a double slit that we used in the previous class. So a slit C is what we are using for this demo. So it's a double slit. And also the diffraction pattern or interference fringes pattern for a diffraction grating, which has 600 slits per millimeter. I have set up here two. One is for the diffraction grating. What you see here is the diffraction grating, and I use the same identical leather, a red leather, which is 632 nanometer wavelength. And here I have the slit C that we used in the previous class, and just watch how far is the screen from this double slit. Okay, so it's about 62 centimeters away from the screen. On the other hand, if you look at this one, the diffraction grating is very close to the screen, and it is about 10 centimeters. I will show you closely these distances. Just pay attention. Here, for the diffraction grating, we need to put the screen very close, whereas for the double slit, we have to put the screen far away. So this is the distance for the double slit, and this is the distance between the grating and the screen. This is the interference pattern from a double slit, and as you can see with the lights on, it is impossible to see the pattern of the interference fringes, and we will try to look at this in a dark room. So this is the interference pattern for a diffraction grating. You can see these interference fringes for a diffraction grating even with the light in the room is on. And you see a significant difference between this interference pattern and what you saw for the double slit. So this is what you see for the diffraction grating in a dark room, and now it's more visible, but you were even able to see it with the lights on. Now I want you to read the distance of the screen from the grating. So the screen is placed at 70 centimeter mark here, whereas the grating, the diffraction grating, was placed at 60 centimeter. So this is the distance between the diffraction grating and the screen. You need that in order to do the whiteboard problem number 2. And also, I want you to read from the scale the first order diffraction and also the second order diffraction. You need also this distance, which is y1 and y2 for m equals to 1, the first order. You need to read y1 here, and for m equals to 2, for the second order, you need to read y2 from the scale. So, for example, for the first order, m equals to 1, I read about 4.5 centimeter, and for m equals to 2, I read about 13 centimeter. So this is what you need to do the whiteboard problem number 2. This is the interference pattern for the double slits. Now you can clearly see the interference fringes. Okay, now I move the diffraction grating to the 10 centimeter mark here, okay? And the distance between the diffraction grating and the screen now is like 1, 2, 3, 4, 5, 6. It's 6 times farther from the screen. And I want you to see what happens to the interference fringes. This is what you see on the screen when I moved the diffraction grating to the 10 centimeter mark. Now I moved the double slit C close to the screen. Right now the distance between the two, the slit and the screen, is about 10 centimeters. So it's very close, okay? And you can not even see the pattern here with the lights on. So let's try if we are able to see the interference fringes in the dark room. And so this is what you see on the screen when the distance between the double slit and the screen is about 10 centimeters, very, very close. So almost you cannot see the interference pattern here. Okay, so this is what you see when the distance between the double slit and the screen is about 60 centimeters. So earlier you saw when the distance is 10 centimeters, and you can figure out what the difference is.